Alright, section 8-6, surface areas of pyramids and cones. Let's get started here with our lesson objectives for this lesson, which are to use models and a formula to find the surface area of a pyramid, and to use models and a formula to find the surface area of a cone. Let's get some key concepts and vocabulary right out of the way, and we start with a pyramid. A pyramid is a polyhedron in which one face, the base, can be any polygon, and the other faces, the lateral faces, are triangles that meet at a common vertex, called the vertex of the pyramid. Alright, the name of the pyramid derives from the shape of its base. The altitude of the pyramid is the perpendicular segment from the vertex to the plane of the base. The length of the altitude is the height, h, of the pyramid. Alright, and then we have a regular pyramid. A regular pyramid is a pyramid whose base is a regular polygon and whose lateral bases are congruent isosceles triangles. The slant height usually denoted by the little L, lowercase, is the length of the altitude of the lateral face of the pyramid. So, going back to our drawings here, because this top picture here, this pyramid over here, the base happens to be a hexagon, has 6 sides. A hexagon, this will be known as a hexagonal pyramid. The vertex of the pyramid is where the lateral faces, all those triangles, they meet right here. So this is the vertex of the pyramid. The altitude stems from the vertex right here, from the vertex of the pyramid to the base, and we call this a regular pyramid if the base happens to be a regular polygon and the sides here, the lateral faces, happen to be isosceles triangles and they're all congruent. The one over here on the bottom will be known as a square pyramid, which is the most traditional pyramid that we see. If you actually tell anybody about a pyramid, this is what they will probably draw, or what comes to mind. So the height, as we stated here, is the altitude. Stems from the height, from the vertex rather, to the base, and it meets at a 90-degree angle. The slant is the altitude of one of the faces, lateral faces. So here we have the slant, and we know it's the altitude because it comes from the vertex of one face and it meets the base of that face at a 90-degree angle. So that makes it the slant. Okay, now let's get our first theorem here going. And the first theorem is 8-9, which states the lateral and surface areas of a regular pyramid. The lateral area of a regular pyramid is half the product of the perimeter of the base and the slant height. The surface area of a regular pyramid is the sum of the lateral area and the area of the base. Essentially what this means is that the lateral area, LA, is going to be defined as 1/2 little p for perimeter and L for slant. Then our surface area is going to be defined as SA equals lateral area plus the area of the base. Now if you realize here, unlike before in which our formula here is set 2b, it said 2b for cones and not for cones, for cylinders and prisms, but that was true because they have two bases. A pyramid only has one base, so since it has one base, we only take care of it once. Okay, now let's take a look at some examples on how to use these formulas and how we actually solve some problems with these. So we have example 1, part A. It says find the surface area of the hexagonal pyramid below. Okay, so here we have the first thing is to define that the surface area is going to be the lateral area plus the area of my base, right? So let's take each of those one step at a time. So the lateral area, by definition in the theorem, stated that that's going to be 1/2 the perimeter times the slant, okay, and then the base, well, plus the area of the base. Now in this particular case, the base happens to be a regular hexagon. Since it's a regular hexagon, it is a polygon, and we can use the area of a polygon. If you remember, the area of a polygon is going to be 1/2 the apothem times the perimeter of the polygon. So we're going to take this area of a polygon formula, we're going to plug it into where B is, so this becomes plus 1/2 a times the apothem times the perimeter. So we have that. Now what we have to do is plug in the actual values that we have. So we have 1/2 the perimeter. Since it is a regular hexagon, that means that each side is going to be 6 inches, and 6 inches times 6 sides, right? Because the perimeter is n times s, in which n is the number of sides and s is the measurement of each side. So this is going to be 6 and 6, which gives me 36, right? So my perimeter is going to be 1/2. This is going to be 1/2 times 36 times the slant. The slant here is given to us to be 9. All right. So we're going to put our 9 here plus 1/2 the apothem. In this example, they do give us what the apothem is. The apothem of the base right here, the apothem is 3 times the square root of 3. So we come in here and we multiply 1/2 times 3 square roots of 3, 3 square roots of 3, times the perimeter. We found the perimeter earlier to be 36, so we put 36 over here. All right. Then we multiply all these numbers and do the calculation. This comes out to be 255.53 and a bunch of stuff after that. Now, it does not say to round out to anything in particular, but I've mentioned before that if the data that they give you or the information that they give you is whole numbers, then your answer should also be in whole numbers. So we're going to round this up to 256. 256. My units are in inches, and since we're dealing with area, it's going to be inches squared or square inches. And that's how we find the surface area of this particular pyramid. Okay? Now, part B is yours. And it goes like this. Find the surface area of a square pyramid with base edges 5 meters and slant height 3 meters. See what you get and compare it to what I get after the little pause. And good luck to you. Okay, so here we have, again, we're dealing with a pyramid, so we're going to use the surface area formula. In general terms, it's going to be lateral area plus the base area. All right, so we're dealing with here, the lateral area is 1/2 the little perimeter times the slant plus, right? Now we're dealing with a square. A square. Since we're dealing with a square, and a square, all its sides are congruent, right? By definition, right? If this side is S, this side is S, so that means that the area of this, of a square in general terms, is going to be essentially S times S is S squared, right? So if it is S squared, then I put S squared over here. Let me actually rewrite that S. It's going to be S squared. Now that I have that, we just go ahead and substitute those numbers or just plug them in. So we have 1/2 our perimeter, and our perimeter is going to be 4 sides, right? It's a square, 4 sides. 4 sides times each side measures 5 meters, so it's going to be times 5. And then we multiply that times 3, which is my slant, right? The slant is 3. Let me make a better 3. Times 3 plus S squared. We go back to the sides and they are 5, so we go and put 5 here, and it's 5 squared. Cleaning this up is 1/2 times 20 times 3. 5 squared is 25, right? This comes to be 30 over here plus 25, and 30 plus 25 equals 55, and our units are in meters, so it's, let me make a better 55. 55 meters area squared, so it's 55 squared meters is our area. That's our answer right there, and that's that for this problem. Okay, let's move on to our next example here. All right, using formulas to find surface area. The Great Pyramid at Giza, Egypt, pictured here on the right, was built about 2580 BC as a final resting place for Pharaoh Khufu. At the time it was built, its height was about 481 feet. Each edge of the square base was about 756 feet long. What was the lateral area of the Great Pyramid? Okay, so lateral area. If you see here our picture, we see that this looks like a square. Actually, just tell what it is, but here's the picture it is. So we're going to take that picture and make it into a diagram, and we end up having this picture over here of our pyramid with a square base, 756 feet each side. Our slant, which we don't know what that slant is, and we'll find out how to calculate it. We know our height, right? The altitude here happens to be 481 feet. Okay, so we're looking for lateral area. We know that lateral area is going to be lateral area equals 1/2 the perimeter times the slant. So we have that out of the way. So we go ahead and plug in what we have. So we have 1/2 4 times S, right? Then I'm just writing that in general. 4 times S, and it's 4 because it's 4 sides on the base, right? And S, well, each side is going to be 756. Now L, how do I find the slant? Well, the slant is not given to us, but we know that if I take a piece, or if I bring the altitude to one of the faces over here and transfer over, we end up with this right triangle over here, in which the altitude here is 481. Since the altitude is 90 degrees here, when I bring it to the face, it bisects the base of the face over here of this triangle. So if I bisect 756, that means it is half 756, which means that this is going to be 378 feet. Okay, because I brought it over here, I'm just going to draw quickly a triangle. So we have this face right here, and it was 756. And if I draw the altitude over here at 90 degrees here, it bisects it. So this side over here is going to be 378, and this guy is going to be 378, and that's where this 378 came from. Now we're dealing with a right triangle, so to find the right triangle, we know we can use the Pythagorean theorem. The Pythagorean theorem states, right, since I'm going to be using L, we can say that L squared equals, right, 378 squared plus 481 squared. Okay, but I need to solve for L, so I would take the square root of both sides, and I'm going to write what I would write over here for L. So this is going to be multiplied times the square root of 400, actually let me follow the numbers that I have here, 378 squared plus 481 squared. Alright, so we plug in the value for S. We have this is going to be 1/2 4 times 756 right there, and this is going to be the square root, and I'm gonna leave myself some space because these are huge numbers. So we have 378 squared is 142,884 plus 378, that was 481 squared. 481 squared is going to be 231,361. Okay, and when we have that, we go ahead and clean this up, and we get on this side 1512 times the square root of 374 245 there, and this comes out to be, let's put my equal sign there, so we have 974.5.573 and a bunch of other numbers there. So again, we only have whole numbers to work with. So since we have whole numbers to work with, we're going to round this to a whole number also. So this comes out to be, surface area is going to be 924,975. Our units are all in feet, and we're dealing with the area, lateral area, so our units are going to be feet squared or square feet. And here we have our lateral area for the pyramid of the Great Pyramid at Giza. Okay, and that's how we do this one. Your part of the problem, part B, and I'm going to leave it there because we're going to be reusing that number. Find the surface area of the Great Pyramid to the nearest square foot. Good luck with this. Okay, so to find the surface area of the whole thing, we know that the surface area is going to be surface area equals lateral area plus the area of the base. Well, we calculated the lateral area right over here, right? Lateral area. So all we have to do now is to find the area of the base. We need to know what the area of the base is. Since we know that the base is a square, right? The area is going to be S squared, right? S squared. So we know that one of the sides happens to be 756. So this is going to be 756 squared. 756 squared is a big number, and that is 536, and its area, so it's going to be feet, right? The units are still in feet, feet squared. Then, since I already know what my lateral area was, which I'm just going to recycle that we have over there, so it is 924,975 plus the new area that we just found, which is 571,536, and when we add that, we get 1,496,511 feet. And the area is feet, and it's going to be feet squared or squared feet. And this right here is our answer for this problem. All right? Good. Moving on to our next portion here. All right, so the next section here of key concepts states that a cone is pointed like a pyramid, but its base is not a polygon, it's a circle. A circle, okay? In a right cone, okay, the altitude is a perpendicular segment from the vertex to the center of the base, okay? The height denoted by h is the length of the altitude, okay? The slant height L is the distance from the vertex to a point on the edge of the base. Okay, here we have this. We have our vertex again over here, similar to a pyramid. Now we have the altitude, and the altitude we have here, and it meets my base at a 90-degree angle, so that's the altitude, also the height. The slant from the vertex to the one edge of the base, right? So it touches my base at precisely one point right there. So that's the slant height. And you're gonna see some of the formulas that apply for cones also apply to that apply for pyramids rather apply to cones, but there is a slight change, and we'll see that in just a second what is different with the next theorem. And we have Theorem 8-10, lateral and surface areas of a cone. And we have the lateral area of a right cone is half the product of the circumference of the base and the slant height. The surface area of a right cone is the sum of the lateral area and the area of the base. Okay, notice now that it says a right cone. Well, as before, when we had regular pyramids, well, a right cone is a right cone because the angle formed between the altitude and the base is a 90-degree, or is a right angle. So we actually call this, right, a right cone. All right, that's why we call it a right cone. So now for lateral area, the formula is going to look somewhat similar, but you'll see the difference now. Lateral area equals 1/2. Now we have 2 pi r times the slant, right? notice that I'm using the formula for the circumference right here, right? Because I want to know the length around. So essentially, right, the area of, not the area, this the perimeter. I'm trying to get the perimeter, right? 1/2 the perimeter, right? The perimeter of a circle is 2 pi r times the slant, right? That's my lateral area. Now I can simplify this better because we have 1/2 times 2, which essentially is just 1. So this turns out to be pi r L, right? All right, so now for the surface area, and it looks almost the same, right? So it's going to be the lateral area plus the area of the base. And the area of the base, well, we're talking about a circle, right? The base is a circle, so we know that B is going to be, right, pi r squared. Okay, so essentially we can say that the surface area of a cone, or a right cone to be more precise, is going to be pi r times L plus pi r squared. So that is what the surface area of a right cone will be. Okay, now let's take a look at our first example here. All right, find the surface area of the cone in terms of pi. Again, it says in terms of pi. That means that my answer needs to have pi in it. So let's take a look at how this goes. So going back to the theorem, and the theorem states that it's going to be surface area equals lateral area plus the area of the base, which we saw earlier that this comes out to be pi r L plus pi r squared. And we just go ahead and plug in the numbers that we have here on our drawing. So we have pi times the radius. They tell us that the radius is 15, so we're going to put 15 here. The slant, they give us what the slant is. As a matter of fact, this surface around a cone right here has an actual name, and this one is called a nap. Actually, let me write that better. The surface of a cone is called a nap. All right. All right. So that we have is to be the slant we have to be 25 right here, and then we have plus pi r squared, and we know that the radius is 15, so it's going to be 15 squared, and then we have that. We go ahead and clean this up. This portion over here comes out to be 375 times pi plus 15 squared is 225, and it's going to be 225 times pi. Okay, then we add those two up and we get this to be equals 600. Let me clean that 600 pi, and our units are in centimeters, and again, since we're dealing with area, it's going to be centimeters squared. And there we have that. All right, moving on to your portion of the example here, and it says the radius of the base of a cone is 22 meters. Its slant height is 10 meters. Find the surface area in terms of pi. All right, good luck with this one. Okay, so on this one, we're told to find the surface area, so we're gonna start with the basics again. Surface area is going to be lateral area plus the area of the base. So we're gonna go ahead and plug in what we know. The lateral area is gonna be pi r times the slant plus the area of the base. Since the base is a circle, it's gonna be pi r squared. And we just plug in our numbers. So we have pi times the radius. Well, that tells us that the radius is 22 meters, so we're going to put 22 over here. Times the slant, and the slant height happens to be 10. So we put our 10 over here. Plus pi, and the radius again is 22, so it's going to be times 22 squared. Alright, so when we multiply this, on this portion over here, we get 220 pi. 220 pi, and then we square 22, we get 484 times pi, so it's 484 pi. And when we combine these two, we get this to be equal 704 pi, right? Our units, though, are meters. So meters over here, since we're dealing with the area, is meters squared. And that's that problem. Hopefully you get the same thing. All right. Next problem that we have here, and this will be our last example. All right, and it goes like this. The funnel here on the right is in the shape of a cone. How much filter paper do you need to line the funnel? Okay, so we essentially want to find out what the surface area of the nap is. Okay, we need to find out what the surface area of the nap. So, in that case, the surface area of the nap is just the lateral area. So we're going to say here, not say here, let's write it here. So, lateral area equals pi RL, right? So we have pi R. Now, let's take a look. We have this right here. We don't know what the radius is. Do we know what the radius is? Well, we know what the diameter is. They tell me that the diameter is 8, right? The diameter is 8. So how do I know the radius? Well, we know that the radius equals diameter divided by 2. So we have 8. 8 divided by 2. Let me write a better looking 8 than that. 8 divided by 2, which is 4. So my radius is 4 centimeters, right? So let's take a look. We have that. Then we know that we need to get the slant. We don't know the slant, but we know that this guy here is 4. Here, right? The radius is 4. This right here now becomes a right triangle, right? I know that this length is 4. I know that this length is 7.5. I can find the slant if I use the Pythagorean theorem. So L is going to be essentially the square root of, and I'm just going to write this in general terms, a squared plus b squared, right? Because we're using the Pythagorean theorem, right? So we have that to calculate, and we can plug in our numbers now and start calculating. So we have pi, the radius we found here to be 4, so it's going to be times 4, right, times the square root of, okay, so we have here is going to be 7.5, 7.5 squared plus 4 squared, close a parenthesis here, and this pi times 4 is 4 pi, times the square root of, let's see, 72.25 when you actually clean this up, 72.25, and this gives me 106.81 and a bunch of other numbers here. Now it does not say what do I need to round this up at all, but since we have whole numbers here, actually we can go, since this one is 7.5 and it does have one significant digit, we can do the same thing here. So that means that our area, lateral area, is going to be 106.8. And since we're dealing with area, we're dealing with centimeters, so it's going to be centimeters squared. All right, so there we have that. All right, part B will be yours. All right, part B is yours. And it goes like this. Find the lateral area of a cone with radius 15 inches and height 20 inches. All right, good luck with this one. All right. It will be helpful, if you find it helpful, to draw yourself a little diagram. I'm going to do my best attempt to actually draw a cone. So we'll laugh later. There. It was going all well until that line came up crooked, so much better, I think. Okay, so we need to have, it tells us what the radius is, so that's actually nice that we have, at least we know what the radius is. So we know over here, we know this length over here. That's my height. It tells me that the height is 20. It tells me that this length over here, the radius, is 15. Okay, so all I need to do is find the lateral area. So the lateral area of a cone is going to be pi RL. So we don't know what the slant is, so we'll need to calculate that. So we will use the Pythagorean theorem to find what L is. So this comes to be pi times my radius. My radius happens to be 15, times, and maybe make my parentheses, times the square root of, and we have 20 squared plus 15 squared. All right, so we have that, and then this comes about 15 times pi is 15 pi, and then we have the square root of 20 squared is 400 plus 15 squared is 225. Close the parentheses. We clean this up a little bit more. We have 15 pi times the square root of 625, and this equals, when you multiply this in a calculator, you get this to be 1178.09, bunch of stuff after that. Now in here, it doesn't say again to round it to anything, but we're dealing with whole numbers now. Whole numbers, so we're gonna round this up to the nearest whole number. So this is approximately 1178. Our units are in inches, so this is going to be 1178 squared inches. All right, and that's it for this lesson. If you have any questions, as usual, you can email me or you can send me a message through Teams, and I'll be more than happy to help you out. You guys stay safe, and I'll see you guys in the next lesson. Have a good one.